Welcome to part 3 of an ongoing research project on anomalous orbs and rods. It's a mixed method study carried out over the last few years in collaboration with Dr. Brian Tyson, United States Department of Defense. He's a colleague of mine that's helped facilitate this project as it's developed and the research behind it over the last few years. I will take you through the methodology briefly because in the previous two presentations that's covered quite extensively. So essentially this presentation brings together the last few years research and talks about some of the key results and their interpretation. So I won't spend too much time on the background. You can access the previous two presentations on my ResearchGate profile under NRGscapes Virtual Laboratory, Andrew Morgan. So let's go into a bit of the background behind it. So same site as the previous two presentations. So it's Karijini National Park, Pilbara, Western Australia, and the environment is listed there for you, and it's an ongoing hypothesis that we've been working with in terms of the scientific method. So you can read it there. If phenomenon can appear anywhere at any time, then it must transit space in the non-visible part of the electromagnetic spectrum because the human eye cannot observe it. In terms of contents, so we have research questions, methods, systems, and sampling. We have frame capture analysis and form variations to talk about in terms of background and methodology. The presentation then takes you through key results. So what we do is we compare all our research results and analysis over the last couple of years across 5 site trips and look at average counts, total counts, comparison by cardinal direction, rod movement by percent distribution and cardinal direction. And we also look at the interdimensional anomaly and compare the two results for that, and of course electromagnetic field intensity comparisons. We then go on to interpretation. So we look at how to interpret the results for counts and movement, differences by size and orientation of orbs and rods to their surroundings, and the interdimensional anomaly. Then we go into what is going on. So we have a look at field repulsion and evidence for field repulsion from the current research program and previous research. And we look at the history of field repulsion technology, torsion fields, 4D scalar potentials, and we come up with a general conclusion about orb and rod technology and its application or potential application. So some of the research questions, so these are ones that are ongoing and form the foundation of the project over the last few years. So in terms of origin, what are they? Where do they come from? What are they doing? What does their presence mean? What does their activity mean? And what areas are they present in? Now we attempt to answer some of those questions, but of course some of them are ongoing questions that we haven't yet determined until we expand the program of research in collaboration with stakeholders or partners. In terms of appearance for research questions, we have how is it that we see them, then we can't see them? Are they cloaked? How is extreme velocity achieved with no acceleration? How is inertia overcome? What is their energy field around them? And what is the source of this energy field? Field methodology. So I've been over this quite a lot in previous presentations, so I won't spend too much time on it. But we use sensor systems in cardinal directions. We take baseline readings and confirm the presence of these orbs and rods, and we look at preliminary observations as well. We record then using these sensors and systems, and we check the data against each other through connections to computer screens and visual capture mechanisms. And then we look at systems and cross-check them through the computer, and then we reposition sensors to other cardinal directions. So it's a combination of methodologies that we've standardized over the last few years. So the systems utilized, We look at imagery through optical and IR. There is the potential for radar, which we haven't done yet. We use spectral photography and radio frequency spectrum analyzers. And again, we have suggested that we expand on some of this significantly with more equipment. We look at signal sourcing, the electromagnetic spectrum, and its measurement and its signature analysis as well. In terms of sampling, this is key because we've really looked to concentrate on standardizing our sampling in terms of the scientific method, so the protocols are repeatable and reliable no matter what site we go to. So at each site, IR video footage is taken at 1 minute intervals, for 1 minute in each cardinal direction. And we also do the electric and magnetic field readings for 1 minute in each cardinal direction as well, or 1 minute for a site location and then repeated across replicates. So at each site, electric and magnetic field readings are taken during the day and at night when filming. And filming and sampling was repeated 6 times over the course of 1 hour for each sampling interval. At some sites we sampled overnight, so 3 times, and then we did repeated intervals for 1 hour at those 3 times. So again, video footage in IR is recorded at 1 minute intervals in each cardinal direction. So that means every 10 minutes we're repeating the process, orientating ourselves to the cardinal direction. And during filming, electric and magnetic field readings were recorded. So you end up with 6 sample times over the course of an hour, and for each of those sample times we record at 1 minute in each cardinal direction. Now, in terms of frame analysis, one of the things we did was try and categorize the orbs and rods into variations or types, and in a previous presentation there is a table summarizing this, but I'll just do the visual here. We essentially got 3 types of orbs. So one was very large, a large white sphere. Then we had a smaller, more grey speckled sphere, and we found this sort of arc skip orb, which we analysed as well, but it may in fact be that that is in fact a large white orb that's just moving dynamically through the field of view, and I'll talk about why that is the case later on. For rods, we got to 3 types of rods as well. The largest one, which is a large white one with undulating lateral extensions. We had a smaller one that was similar in size and shape but appeared to be smaller. Now again, we've got to account for distance when we're filming as well, so it may in fact be that these two are very similar in terms of size. And then a smaller one that had a very distended shape, almost like the juvenile form of a large rod. There were form variations amongst all this. So we had shorter, large white ones that appeared to, I would say, look more stunted in terms of their appearance. Then we had this extended one with a thicker central rod, but still with the lateral extensions that spiraled around it. And then we had this very long, elongated one with a much thinner central rod, and of course this lateral extension that's rotating or spinning around it. In terms of the form variations for orbs, we had this speckle-sized mid-sized grey orb that would move through the field of view. We also found this very small, smooth grey orb that would have a very erratic movement and close to the ground or well above ground along the tree line. And then here's this arc skip one that I talked about. Now we have come to the conclusion that that's just the distended form during movement of a large white orb. So next I'd like to go through the results and comparison between all field trips before we get on to the more interesting interpretation of those results. So let's have a look at those. Here we have average counts, or a comparison of average counts. Now you can see here we've got trip 2, trip 3, and 4, and trip 5 across 2 nights. Now trip 4 was a different location, about 30 kilometers from the site we've been back to repeatedly. And then at trip 5 we actually sampled across 2 nights for orbs and rods. I'd like to point out that at site 4, which was a different location, there appeared to be no difference in counts or average counts between small and large orbs and small and large rods. Now if you look at trip 2, for example, you can see there's quite a significant difference between the number of rods that are large and small and the number of orbs, although the ratios appear similar. Now this changes when you go to different sites, so you can see that there's not really a consistent trend, and it does vary depending on the field trip that we went on and the proportional ratio between rods and orbs. If you look at total counts by comparison, now this gets more interesting, because when we recorded overnight, the numbers dissipated. For example, if you look at trip 3, 8 to 9 p.m, now this is when peak observation occurred for all sites. When we did our field work was after dusk, and the early hours of the evening was when the counts were highest. Now when we stayed up overnight and did our midnight sampling, you can see that the numbers are reduced, and then the early hours of the morning activity is at its least. Now if you look at trip 5, we can see, although the numbers are reversed, peak activity again is at the same time and then reducing overnight, so midnight and then early hours of the morning. And then when we did sample on the second night in trip 5, you can see the numbers are back up again, although the ratio is reversed. Now by cardinal direction was interesting. Again, we have trip 2, trip 3, trip 4 and trip 5. You can see at the different site we went to that the numbers are down significantly, but again, overall there's no preferred orientation to cardinal direction, and this is a lot more evident in the other trips, where you can see that there's no real preference for orientation by cardinal direction when you take total counts of orbs and rods. We looked at proportional percentage distribution, and again it's difficult to determine an overall trend between trip 2, 3, 4 and 5. And I just took, for example, if you were looking north, then you've got the percentage travelling east here is 24%, and if you do the same in trip 3 looking north, and then the percentage travelling east, and so on for each of them. And that's how this works again. So the first cardinal direction is the direction you're facing, and the second cardinal direction is the direction of movement. So it does vary trip by trip. There is some sort of trend here for looking north, and then orbs and rods travelling east and west, but you can see it varies quite a lot. And in trip 4 we find that that number is reduced in that cardinal direction and then picks up in another cardinal direction. So I wouldn't say there's an overall trend there, and it does vary. It's quite a centralized orientation. What we did is look at rods in particular, because they have extreme velocity with no acceleration, and that was interesting. So you can see here, for example, for trip 2, when facing north, more rods were observed moving east and west of the observer. And then if you go to trip 3, for example, when facing west, there were more rods observed moving south of the observer. So that's over here, and that's how this works when you look at it by cardinal direction of movement across trip 2, 3, 4 and 5. And we were looking at orientational trends overall. Difficult to ascertain here, but we can see there is some trend here in trip 2 for rod movement being north and west. Over here it sort of orientates more around to the west, and then down here more to the east, moving north and south. In terms of the interdimensional anomaly, now in previous presentations this interdimensional anomaly was picked up in IR video footage as a kind of haze with what I call ghosting of orbs moving through it, and you can see that on the IR video footage, and we just looked at the direction of the ghosting to determine the direction of the interdimensional anomaly that was moving through the location. Now in this trip here you can see that the orientation from and to was sort of northeast, okay, to southwest, and then here it appeared to be northwest to southeast, and what we found was that the orientation of rods tended to be in the direction of the interdimensional anomaly. What was interesting here was looking at electric and magnetic field intensity across all trips. Now in the trip 2 we just did one recording at day and one at night of electric field intensity in voltmeters, and then over here in microteslas, and you can see there was a general trend or significant difference between day and night for both. Now when we got to trip 4 we did a more rigorous sampling regime where we looked at 8 AM, midday, 4 PM and 8 PM when we were sampling, and you can see it peaks here in midday and 4 PM and then drops off significantly at 8 PM, and then when we looked at it overnight the electric magnetic field intensity had dropped off to near zero, and then in the early hours of the morning during the day it builds up again, and then again at night it drops off. So I'd like to now talk about interpretation of the results and what we think they may mean, and put that in the context of some wider research or background research in certain areas. Alright, so what we found is when we looked at counts and movement, is that the counts of orbs and rods appears to be location centric. So it's orientated around some sort of center. Now it was difficult to determine if there was a relationship between orbs and rods, both in terms of size and counts overall when you take into consideration all the field trips. What we do know is that activity always peaked in the early evenings after dusk when it was dark, and it coincided with a reduction in electric and magnetic field intensity that built up during the day. Now total counts of orbs and rods did not show any bias towards cardinal direction. However, orientation of rod movement relative to cardinal direction appeared to be aligned with the direction of the interdimensional anomaly that was recorded. And rods appeared to manifest and move off, and they follow in the slipstream of the anomaly. And you could see the ghosting of orbs that reflected that slipstream as well. Now, if you look at differences by site, manifestation was still location centric, and the electric and magnetic field intensity measurements were similar at the alternate site compared to the main site. In other words, that was a different location about 30 kilometers away with significantly less orbs and rods, but a similar electric and magnetic field intensity measurement. Now it builds up during the day, this electric and magnetic field intensity, and dissipates overnight. Now that's irrespective of the site. Overall, it was difficult to determine if there was any relationship between the magnitude of that electric and magnetic field intensity at each site location and the numbers of orbs and rods that were manifesting. Now in terms of orientation to surrounds, orbs and rods, they exhibit characteristics of object avoidance. Now in presentation 1 and 2 we talk about that quite a lot, and what features of orbs and rods may allow them to demonstrate object avoidance. So I won't go into that in too much detail here, but if you look at the previous presentations you can read all about that. Now what's interesting is we talk a lot more about the energy field that appears to surround the orbs and rods and assist them in negotiating their surroundings. Now in presentation 2 and 1 we talk about a signature that we picked up that may have something to do with object avoidance and orientation to surrounds as well. So again, look at the previous presentations for a discussion on that. There are no observable features characteristic of airframes, but so it appears the energy field enables orbs and rods to overcome inertia and the effects of gravity and orientate themselves to their surrounds. Now, we suggest that the energy field may be powered or linked to the build-up of electric and magnetic field intensity during the day, and as it dissipates overnight, it's been consumed or harnessed by these orbs and rods, and shortly we'll discuss why we think that may be the case. Now, of course, early in the night, the numbers of orbs and rods manifesting was greatest and decreased markedly as the intensity of the interdimensional anomaly participated. So the energy associated with movement didn't change in terms of velocity with no acceleration, but the numbers of orbs and rods decreased. Now, in terms of the interdimensional anomaly, okay, orbs and rods that manifest seem to be constrained or contained within the anomaly, within the field of view, that is, or the range of the field of view. Now, the anomaly appeared to allow for orbs and rods to be projected into our physical dimension, of course, because they're orientated or being contained. And when you look at the ghosting, there appears to be a lot of orbs that ghost without fully manifesting. So relative to the observer, it creates what I call a looking glass effect. That should be effect, not effect, whereby the observer can see the event, but you're not affected by the event. So in other words, when I'm doing my field work, I'm right in the anomaly, but do not appear to be physically affected by the anomaly. In terms of the opening to the anomaly, we think it may be activated by a concentration of the build-up of energy in 4D scale of space during the day. That's our suggestion when you look at the results. So when the anomaly is fully open, you've got this potential energy in 4D scale of space converted to kinetic energy in a 3D vector field, which allows these orbs and rods to orientate themselves when they manifest in our physical dimension. So we suggest, and I'll talk about this shortly, that there's some sort of field repulsion technology utilised or harnessed by the orbs and rods. Now that's either innate to the object or it's acquired, which then enables them to consume or harness this energy. Now we talk a little bit more about the features of the orbs and rods in the previous presentations. So if you want to look more at that, I suggest, or strongly suggest, looking at our previous presentations that have led to this third one you're listening to now. Now in terms of the energy, as the energy of the surrounding anomaly is consumed by the orbs and rods, it dissipates and the anomaly loses energy and eventually closes and then has to build up again during the day. I'd now like to spend a bit of time discussing what we think is going on and then relate that to a bit of background research in this area so the reader has a better understanding of why we've come up with these suggestions or interpretations of the results that need looking into in more detail. So let's look at the orbs and field repulsion. Now if you look here at the image analysis and we look at this arc skip rod we talked about, we've looked at evidence for two lateral extensions that spin around it. And what we found is we've got this extension here and you can see it bisects the sphere, and then there's another one here with more intensive image analysis. Our suggestion is that this creates a spin around the orb at extreme speed, which helps harness the energy from the interdimensional anomaly in a 3D vector field from 4D scalar potentials. And then if we take a look down here, we've got another image analysis and we can see that surrounding the orb there appears to be this energy field or lateral extension, and we suggest that that's spinning around it at extreme velocity with no acceleration. But if we look at the smaller one over here, we don't seem to get that. The smaller orb seems to be quite speckled. That still overcomes the effects of inertia and gravity, but its movement is a lot more erratic than the larger orbs that move through the field of view. Now, we suggested there's a relationship between electrostatic charge and inertial mass reduction, and that the energy is harnessed from its surroundings by these lateral extensions associated with the orbs. And you can see evidence here perhaps that they're spinning around the orb at extreme velocity. Now, we suggest this creates torsion around the exterior of the object and a field that overcomes the effects of gravity. So let's look at the rods add field propulsion. Now, in terms of electrostatic charge and inertial mass reduction, again we've got this energy being harnessed from its surroundings by lateral extensions that are spinning around the rod, and we did some image analysis to try and pick this up in more detail. And again, similar to the orbs, this creates torsion around the exterior of the object and helps overcome the effects of gravity. Now, over here, if we look at two types of image analysis of two different rods, we can see moving down, this is a sequence or a photo sequence here of the lateral extension spinning around the rod, and these are just slightly different enhancements using image contrast and sharpen until we get to this one here, where it's quite a nice image of this rotation or lateral extension that is spinning around these rods. And again, the same thing here, we've got a image sequence here with different image sharpness and contrast being applied to try and get a lot of detail around this. Here we've done an enlargement, which I particularly like. We need to do a lot more work with image analysis and enhancement and looking at this. But if you look at that first one, you can see here we've taken an enlargement showing this lateral extension here that appears to be spinning around the rod, and optimized enhancement and contrast to try and pick it up. And we can see particularly here, this has come up quite nicely, seeing this lateral extension. It seems to be almost wrapped around the center rod and spinning at extreme velocity. And in the longer one, which is elongated and probably up to 1 meter long, again quite nicely we can see that it seems to be almost wrapped or like a spindle around the rod, moving from anterior to posterior. What I'd like to do now is take a little bit of a look at the background history of field repulsion technology. Now, these authors are historical figures. For example, Dr. Ningley and Douglas Torr. Now, in the 1980s, they fabricated a disc that produced a force field capable of repelling objects of significant mass. Now, it produced a gravity-like effect, and how it worked was related to an unusual state of matter generated in the lab, the Bose-Einstein condensate. Another figure in history people may be familiar with is Victor Schauberger. Now, he was a forester that spent many years observing vortices in nature and the way water tended to form these natural inward spiraling vortices. Now, during World War II, Hitler heard of him and apparently seconded him to apply his knowledge in the construction of flying disc technology using air suction and suction turbine implosion engines. Another person people may be familiar with is Otis Carr. Now, in 1955, he did found a company in Baltimore, Maryland, and filed a patent to work on a model of a flying saucer. Now, it consisted of counter-rotating plates, electromagnets, and capacitors. Now, the flying disc used electrostatic charge and an inertial propulsion system. There's quite a history behind Otis Carr, and he was taken to court by the FBI for fraud, and has quite a checkered history in that regard. And there's quite a lot of innuendo around his career and what he achieved. But a paper has come out recently that looks at the mathematics and physics behind his invention. I do have a copy of that paper. if anyone is interested in it. Torsion fields is another interesting one. Now, there's a lot of work by Russian scientists on this, and it's quite hard to find in the literature. And again, they look at spiraling vortices and in terms of torsion fields, and I suggest that there's a lot of connection there with counter-rotating plates around central objects that represent mechanisms by which torsion is created. Now, the question is how to connect that with repulsion fields, of course, and electrostatic charges, where this is harnessed in a torsion field, which is generated as a result, and gravity is repulsed. So an object like a UFO or UAP or flying saucer or disk, or indeed orbs and rods in the present study, are then able to pull themselves along. Now, I've got the authors here and the researchers: Shipov, torsion fields and the manifestation of energy; Pavlenko, torsion fields, what they are and their influence on biological organisms; Korsarev, torsion fields and the science of time. And then we get into De Palma and the N machine, and Faraday and his homopolar generator. But I'd like to pay a particular reference to the Russian scientists and their work on torsion fields, because the work's quite hard to come by, and it took a bit of work tracking down their papers, of course. And finally, we talk about Maxwell, right? Now, he is infamous or famous for his electricity equations, of course. But what I'd like to say is that his original work was connected to four-dimensional space, or 4D scalar potentials. Now, that was written out of his work by Heaviside, so no one really knows of its existence in modern day electricity and physics. Now, his original model was picked up by the US Army, and what we've got here is that they thought that his original model had the potential to unleash limitless amounts of energy and allow gravity to be engineered at the quantum level. But you need to track down an original version of his 1873 copy of Maxwell's treatise about hyperdimensional quaternion notation, or 4D scalar potentials. Now, this guy Heaviside edited all that out of his equations. So by 1892, the corrections to Maxwell's original use of scalar potentials removed the crucial distinction between 4-space geometric potential and 3-space vector fields. So that means there was no testable physical proof of hyperdimensional physics. So the potential solution to unifying major laws of physics disappeared. Of course, quantum mechanics took over, and relativity with Einstein supplanted hyperdimensional physics, and the fourth dimension became referred to as time by Einstein. So if we follow the suggestion in the geometric treatise by Maxwell, then 4D scalar space can be entered into by creation of an energy vortex, and that's where I try and link the previous authors I mentioned about torsion fields and repulsion fields up with Maxwell's work. So after all, is an atom not a vortex first, then a particle? So we talk about waves and particles, and the two-slot experiment, of course. So the fourth dimension, instead of being referred to as time, could in fact be based on Maxwell's geometric scalar hyperdimensional 4D space. Now, in terms of orbs and rods, what I've got here is that 4D scalar potentials may allow for the discharge of energy into 3D vector fields along magnetic field lines. Now, field repulsion technology of orbs and rods may harness this energy, allowing objects to orientate themselves to their surrounding environment when manifesting through an interdimensional anomaly, portal, or a wormhole. So what I'm trying to do here is link up torsion field research with field repulsion research, and Maxwell's original work that was edited out of the public arena in science as a background to discuss the mechanism by which these orbs and rods utilize technology to orientate themselves to their surroundings within an interdimensional anomaly. So again, in mainstream science, this work has all disappeared, all been taken offline. I don't know whether that's deliberate or just as a consequence of the progression of the consensus of science, but I am suggesting that we are missing a massive proportion or significant area of science that resulted in a lack of understanding of the nature of reality and what space really is. And of course, that limits our ability to traverse space and travel to other star systems. So that's where it's at the moment. So I'll just carry on from there and start wrapping this up without getting into too much of a discussion about the science behind all this, of course, because moving forward we want to delve into this in a lot more detail. In terms of research, and I do have research proposals and business cases written around doing that moving forward. So what's the conclusion here? Let's just talk about it. So in terms of electrostatic charge and overcoming inertia and the effects of gravity, what we've got here, number one, a localized electromagnetic field that connects scalar geometric potentials, so 4D hyperdimensional space, to a vector field in 3D or physical space that concentrates available energy and opens a portal or wormhole. In other words, an interdimensional anomaly. And the other thing to consider is that these orbs and rods have a device or structure around them that consists of some sort of nanofiber technology that harnesses that energy and accumulates it as an electrostatic charge through spin and torsion or vortex generation, in other words, field repulsion technology. So in the case of orbs and rods manifesting within an interdimensional anomaly, the energy source may be electric and built up or concentrated along magnetic field lines or ley lines of the planet during the day and discharged overnight. So here we have the conclusion that we've got 4D scalar electric potentials involved in transferring energy into a three-dimensional vector field in physical space, and that there's a relationship between interdimensional anomalies and the manifestations of orbs and rods in that regard. Now the technology behind that is very interesting, and that's why I'm quite keen to pursue a line of thought about electro-spun nanofiber technology in terms of engineering these things ourselves and getting much better insight into understanding what they are, where they come from, what they're doing, and what their presence means. So I'll leave the presentation at that for now. I encourage you to go through presentation 1 and 2 before delving into presentation 3 to get the context behind this enormous amount of work that we've achieved so far. And I look forward to pursuing it further with interested parties and stakeholders. So again, thanks to Dr. Brian Tyson, United States Department of Defense, for being involved in all this, and we look forward to what the future brings.